Bismillah ar-Rahman ar-Rahim. This lecture, we are going to continue our discussion of K-maps. And today we are going to discuss the three variables K-map, okay? And believe it or not, the same ideas apply in the three variables as well as the four variables and 5 and 6 variables, K-maps. All of them basically rearranges the cells in the truth table such that adjacent cells are different by only one literal. Okay, so here we are showing the K-map of a three variables function. Okay, so we have A here, okay, that goes from 0 to 1, okay, and it is composed of 8 cells here. And we have BC, two variables here, goes this way horizontally from 0, 0 all the way to 1, 0. Notice that the way we do it is 0, 0 followed by 0, 1 followed by 1, 1, not 1, 0. Okay, 1, 1 and then 1, 0. Why did we change the order here? To respect the adjacency, so that these two cells are adjacent, so they change by only one literal. And these two cells are adjacent, so they change by one literal. For example, this cell here, okay, corresponds to pattern 0, 1, 1, 0, 1, 1, okay? And this cell here is 0, 1, 0, okay? So the only change here from here to here is that C goes from 1 to 0. A and B are the same, okay? So that's why these two cells are adjacent. By the same way, okay, we know that this cell here is also adjacent to this cell. So the K-map wraps around the boundaries, okay, the edges. So this cell here is 0, 0, 0, and this cell here is 0, 1, 0. So they are different only by with respect to variable B, which is 1 here and 0 here, okay? A and C are the same. The same goes for this one and this one. Now we have this function, which is 0, 1, 5, 7, the sum of these min terms, okay? And we would like to minimize it using K-map, okay? So we plot the ones of this function, which are basically at cell number 0. So min term number 0 is here for this function. It belongs to this function. And 1, okay? And then 2 and 3 are missing here, and then 4 is missing as well. 5 is there, and 7 is there. So this is 7 here, okay? So who can tell me what this little number here represent? Anyone? Who can tell me? The question is, who can tell me what this little number represent?
Represent the combination of A, B, C. It's 0, 1, 1.
Excellent. So it is the decimal value of the binary ABC, which is 0, 1, 1. So the decimal value is 3 here. It's basically the box number, okay? It's the min term number. So the min term, this min term here is missing from this function, okay? So this function is nothing but these 4 ones here, okay? All right, so one thing that you need to remember, okay, is that you don't, so for grouping the ones, okay, we group the adjacent ones together, okay? But you have to make sure that you don't double cover, okay, a one more than once, okay? You don't cover a certain one more than once unless absolutely necessarily. If it's not necessary, then you may introduce redundant terms into your function, okay? So here, for example, I can take this and this as one group. Okay, 1 and 1. These I can group them together because they are adjacent. Okay, and it is a power of 2, and it is a rectangular shape. Okay, and these two also I can group them together. Okay. However, I know that I can group these two together, but since this one is covered by this group and this one is covered by this group, I don't see any reason why I need to cover this. Okay. So there is no reason for covering this group here. Okay. So double covering is only done when absolutely necessary, as we will see in a later example. Okay. So as I said, the double covering will result in a non-minimal function. So let's see. So this function here minimizes to this group here. Okay. And from this group, what literal is going to disappear? Which literal is going to disappear? It's the one that is changing. Remember, the one that is changing. Okay, so in this case, it is literal what? C. C here is changing from 0 to 1. Okay, so this one here is A complement because A is 0 here. Okay, and B complement as well because B is 0 here. Okay, and for the green box, it is A because A is 1, ended with C because C is 1. And B will disappear because it changes from 0 to 1. Okay? So my function simply is A complement, B complement, ORed with AC. Okay? And this is the minimal sum of product. Now you may ask me, what happens if I also take this group as well? What is this group here?
B complement C.
B complement C. Excellent. And what can you tell me about this term here? From Boolean algebra that we learned so far, unit 2. Remember one of the theorems that we studied, for example? It is the consensus term of these two terms, A complement, B complement, and AC. Okay, so if you take the consensus of these terms, you'll get B complement C, B complement C. Okay, and we learned when we studied consensus theorem is that the consensus term is what? Redundant. Okay, and we don't have to use it. So again, this is just the consensus theorem or a proof of the consensus theorem using K-maps. Okay. All right, so we don't need this. Okay. All right, so let's move on unless you have a question. So in this page here, I'm just stressing the rules for grouping minterms or ones of the functions. Okay. And these rules, okay, are valid for all K-maps of all sizes, okay? All right, so they are valid for all sizes of K-maps, whether 3, 2, or 10 variables, whatever number of variables that we have, okay? First of all, the first rule is that the shape of the grouped minterms must be rectangular, okay, of rectangular shape. Okay, so will a square shape satisfy this rule or not?
Yes.
Yes, because a square is a rectangle basically, but not every rectangle is a square. Okay, so the first rule is that the shape of the group minterms must be of a rectangular form. Okay, the second rule, and there is an ending between them, so they must be both rules must be satisfied, or all the three rules must be satisfied. Okay, the number of group minterms must be a power of 2. Okay, must be a power of 2. All right, and the third group, this is this is the most important rule here. Maybe it's the one that we are going to probably have some examples about. is that the rectangle of the group must not be completely contained. Okay, it must not be completely contained inside a larger rectangle. A larger rectangle which satisfies both conditions 1 and 2 above. Okay, meaning that this larger rectangle contains the power of 2 boxes or squares, and it is of rectangular shape. Okay, all right. So for the if you want to group in K-maps for the minimality, to guarantee minimality of the expression, okay, all 1, 2, and 3 must be satisfied for all the groups. Otherwise, minimality will not be guaranteed. Okay, all right. Let's see this in action now. So we would like to simplify this 3 variables function, okay, using K-map. If you want to plot it, okay, this is the plot of this function. Okay, these are the ones of the function. Okay, 0, 1, 2, 3, 5, and 7. 0, 1, 2, 3, 2, 3, 5, and 7. Okay. Okay, now this is what we from the rules that we learned in the previous page. Okay, we know that group M0 with M1, this group here, okay, and M1 with M3, and M2 with M3, okay, and M0 with M2, because they are adjacent, remember, okay, are not considered. Why? Why aren't they considered? Because of what rule? Which rule? Rule number 3. Because they are completely covered by a larger group. What is this larger group? It is the first row. Exactly. So this group here, it contains all of these smaller groups. Okay, and it is actually rectangular form and power of 2. So it is considered. So these groups are not considered for minimality. Okay, we only consider the largest group that covers all of them. Okay, similarly, okay, these two, M1 and M3, and M5 and M7, and M3 and M7, and M1 and M5 are not considered because they are contained inside of this larger group. Okay, all right, do you see that? Any question? So the only 2 groups that we have is this big group and this big group. Notice that there is a double covering here of these 2 ones or min terms, but that's fine because we are using it to our advantage. Okay, so the other alternative is that we only cover it this way, this one and this one. However, this violates 2 conditions here. Okay, the first condition is that this one here is contained inside of this one. Okay, the second condition is that actually it's just this one condition. So because this is not this is completely covered by this larger group. Okay, and having this only will result in a non-minimal function. Okay, so the correct way of grouping them is to have this, okay, which corresponds to a complement, because B and C are all dropped. Okay, why? Because they are all changing. Okay, however, A is a constant 0 here, so it's a complement. And here in this green box, the C is the only one that is not changing. So it is 1. So this corresponds to a C. So my function is in simple terms, or in the simplest form, is a complement ORed with C. Okay, any question? This class is dead. Actually, there are no questions.
It's clear to me.
Hopefully it is clear.
Yeah,
Can we
it is.
have another example just to make sure it's clear?
We will have another example, but is this example clear or not? If you have a question, then make sure that to ask, please. Okay.
Doctor,
Yeah.
we take the first row, but what if we take the two separate, like
I've-
0 and 1 and 3 and 2?
Okay. All right. So instead of taking this big, larger group, you're suggesting to take like this.
No,
Zero,
I mean
one.
we add to the if, like we take the big group and take also the small group.
The small group here, the 0 and
Yes.
1 and 2 and 3, right?
Yes.
Why
Yes.
don't we take this as well? Why don't you take this as well? This is a question to you. Just to, I mean, in order to like think like you now, I'm asking you, you just took this and this, but you didn't take this as well. And you didn't take this also. Okay?
Isn't are we going to get all the groups that we can get from the scheme up?
Okay, so you haven't paid attention here because I have already discussed your question. Okay, so pay attention, please. Okay, pay attention now. So the reason why we didn't take this and this, okay, is that they are contained in this larger group. Okay, if something is contained in a larger group, completely covered by a larger group, then you don't take it. Okay, you don't take it because it will introduce redundancy in your function. Okay, you get it, yeah, Abdullah? So these are the golden rules. You are violating, if you do that, you're violating rule number 3 here. Rule number 3, what does it say? The rectangle of the group must not be completely contained inside the larger rectangle satisfying 1 and 2 above. Okay, so in your example, if you take 0 and 1, for example, it is already contained inside of the big rectangle here. Okay, do you see that?
Yes.
Yeah, that's why.
No, it's not clear. No, it's clear. Thank you, Doctor.
Yeah, sure. Thank you for asking, by the way. Okay, next. 4 variables K-map. Okay, 4 variables K-map. Now, believe it or not, it is the same concept. The only difference is the ordering of the cells or squares inside the K-map, okay, in order to maintain adjacency, okay? So this is how the K-map is drawn here. Let me just raise this. Right, and all right, so the K-map, the 4 variables K-map is drawn this way. So we have here in the vertical direction, we have AB, okay, or whatever your variables are, AB or XY or whatever, AB, and they are going vertically down, okay? And then we have CD, and they are going horizontally to the right, okay? So AB is 0, 0, 0, 1, 1, 1 again, okay, and then 1, 0. Why did we do 1, 1 and then 1, 0? Because to maintain adjacency, okay? And the same thing here applies between 1, 1 and 1, 0 to maintain adjacency. However, in this K-map, there is a more important thing that is going on, okay? So here, the 4 variables K-map, okay, the first row is also adjacent to the last row, okay? And the first column is also adjacent to the last row, okay? I mean, to the last column. and by this, okay, we have the corners, okay, are adjacent to each other. Okay, so you can think of this as we are as if we are folding this K-map here. Okay, we are folding it against each other like this. Okay, folding it to be adjacent to each other. Okay, from this side, from the top side, okay, to the bottom side, as well as from here to here. Okay, forgive my drawing skills. Okay, maybe I'm not a good illustrator, but you get the idea. The idea is that this K-map is actually it actually looks like a torus or a donut. Okay, it looks like a torus or a donut. So just if you fold the K-map, okay, once in the vertical direction, okay, then the first row is going to be adjacent to the last row, and then fold it twice, second time, in the horizontal direction, so that the first column is adjacent to the last column. Okay, and in this case, in this way, we have the corners. Corners are really adjacent, and they form a square. Okay, so if you have this function here, okay, we would like to simplify it in the simplest sum of min terms form. Okay, I have Faisal, you shared something here. Is it the
Oh
you,
yeah,
want, you
sorry.
want to show us? You want to show us something?
It's just the donut you talked about.
Yeah, actually, I'm not sure of how do I display it to. But anyways, you guys open it and look at the. Yeah, exactly. This is the donut. So this is why you have the the donut shape. So it's just the K-map is folded twice. Okay, once vertically and then the second time horizontally, and then you have the corners adjacent to each other. Okay. Any question regarding this? Thanks, Faisal. Thank you for showing us this illustration. Okay, now for this function, okay, again, the rules apply. The rules that we learned apply here as well, okay, in 4 variables or whatever number of variables K-map that we have. Okay, so for this function now, how do you suggest that we group or take the first group? Who can tell us the first group?
The 8 in the middle. The 8. I mean 1, 3, 5, 7.
Yeah, let's say
30.
first column, second column, first row, second row,
Yeah,
like this.
Second and third column.
Excellent. Okay, so these are one group. Why?
Because it's
Rectangular.
rectangular and
Power of 2.
to the power of 2. Yeah.
Yeah, and not completely covered by a larger rectangle. Excellent. Okay, so this is one example, one group. Okay, who can tell us another group?
The first row and the last row.
Excellent. Okay, excellent. I mean, you guys are excellent. Okay, you didn't do any mistake here. Okay, so what is wrong? What is wrong with this solution here? Let me see.
We can
Maybe someone.
more minimalistic.
Come again?
We can make it more minimalistic. يعني نقدر نبسطها أكثر.
You want to make it simpler than that? Okay, how can you do that?
We can take the numbers in the corners, like 1 and 4.
Yeah.
8
So
and 7.
instead of taking the big group of the big green box, you just take the smaller corners, right? This is what you're suggesting.
Yes.
Okay, let's do that. Okay, let's do that and see what happens. Okay, so this one here, our colleague is suggesting this solution instead, because he's saying, why double cover these ones? Okay, the ones in the first or second and third column. Why double covering them in the first and last row? Okay, so we just want to do it this way. And who can tell us what is there is something wrong about this solution? Who can tell us what is wrong about this solution and which rule did we violate?
We violated rule number 3.
Why? What is that rule? So the green box here is what? Completely covered by
A
One.
bigger box.
a bigger box, which is the first row and the second and the last row, right? You see that? Who was the original ask? Who asked? The
I'm
original
the one.
question? Yeah, so Muhammad. So do you see the reason why we didn't do this? So this is wrong. Okay, this is wrong. Why? Why is it wrong? Because the green group here is actually contained in a larger group. Okay, in a larger rectangle. What is that larger rectangle? Let me use a different color here, maybe orange. This is the larger rectangle. Okay, you see that? Yeah, so whenever you want to do that, so now when you go back home, okay, actually you are home, but when you are doing your homework, okay, try to compare the minimal expression of this function with the expression of taking the corners only. Okay, taking the corners only will result in a non-minimal expression. Okay, so who can tell me what is the expression corresponding to the orange group here? So the change
complement.
B complement, excellent. B complement. Why? Because it's the only constant and it's 0. Okay, the rest of the literals are changing. Okay, what about the red one?
D.
C, excellent. Actually not C, D. Yeah.
D.
Why? Because D is 1 and all the remaining literals are changing from 0 to 1 or from 1 to 0, whatever. So my function is what? D ORed with B complement. Okay, and if you minimize it using what Muhammad suggested, just the corners instead of the first and last row, you'll notice that this term will be containing one more literal. Okay, it will contain actually it will be a D ORed with I think it will be D complement B complement. Okay, yeah, D complement B complement. Okay, and that using the simplification rule can revert back to this using Boolean algebra. Okay, so this is a non-minimal expression. Okay, all right, let me just erase this and then move on to the next example here. Okay, we would like to, oh, I'm sorry about that. I didn't have time to erase the, all right, so that's the disadvantage of having a back-to-back class. Okay. Okay, so we would like to minimize G, which is a function of A, B, C, D. Okay, and having these min terms here. Okay, we have these min terms. This is the function plotted here. Okay, and we would like to minimize it into minimum sum of product. How can we proceed? Who can suggest a group for us?
The corners.
The corners, excellent. Okay, the corners are a power of 2. They are 2 to the 2 squares, rectangular shape, and they are not contained in a larger group. So the corners are an excellent choice. Okay, and what does the corner correspond to? What expression? B complement. What?
A complement.
Yeah, B complement ended with
C complement.
yeah, C complement. No, C complement, is it? Yeah, C complement. I was comparing it with this one, but that was different. So some reason this was erased here. Okay, this is 1-0. Okay, so the C is not changing. The D is not changing actually. The D is not changing. It's B complement, D complement. Okay, D complement. You see that? So the D here is not changing. It's 0-0 here. Okay, whereas the C is changing. Okay, so B complement, D complement. Okay, that's one expression. What's next? What's the next group? Someone, please.
3 and 2.
3 and 2, excellent. Okay, so 3 and 2 are candidate, a good group. Okay, and the rules, all the rules apply. So what is this now? A complement is constant. B complement is a constant, and
C.
excellent. Yeah. What's a third group?
8 and 9.
8 and 9, and that's a B complement.
C complement.
C complement. Yes, C complement. Excellent. C complement, because the C is actually fixed 0 here. Okay. All right. The final one is
10
this
and
one.
40.
Yeah. Let's take a different color here. 14 and 10, and that's what? That's A.
C, D complement.
D complement. So A complement, B complement, C. That is my G here. Okay. It's a G, right? Yeah. ORed with A, B complement, C complement, ORed with A, C, D complement, ORed with B complement, D complement. Now I challenge you to try Boolean algebra and try to minimize this expression, okay, to a sum of product form, of course. Okay, you will not be able to do that because it's already the simplest form. Okay. All right.
دكتور
Yeah.
ليش ما عندي سؤال، ليش ما ناخذ 14 10 and 2؟ هل تعتبر adjacent هذه كلها مع بعض؟
طيب, okay. Excellent question. So Muhammad is asking, why don't we take 2 with 10 and 14? Okay, so I'm going back to the rules, and I want you, Muhammad, to answer me which rule did we, if we do that, which rule are we violating here? Let me just make it smaller so that you can see all the rules. Muhammad.
ممكن 2.
Rule number 2. What is that rule number 2? Which is
number of grouped min term must be a power of 2.
and the number of min terms that you're grouping is not
3.
a power of 2, which is
Yeah,
3,
yes,
right?
yeah.
It is not a
Okay.
power of 2. That's why. Okay, that is
Okay.
why. That's answer your question. So we cannot group 2, 10, and 14 because the number of min terms that you're trying to group is 3, although it is rectangular, and may not be contained in a larger group, but it is not a power of 2. Okay, it must be a power of 2. It must be rectangular. It must not be contained completely inside of another group. Okay. All right. Excellent question. Thank you. Okay, now note that we can use K-map also to simplify any Boolean expression. Okay, so far in our examples, we only gave expressions in sum of min terms, okay, which is equivalent to a truth table, basically providing a truth table, okay, and then plotting the K-map like this. All right. However, it doesn't have to be this way. Okay, so if I give you a Boolean expression, a generic Boolean expression that is not a sum of min term, a canonical form, then you can either convert that expression to a sum of min term and proceed as before, or you can convert the expression to a sum of product, rather than sum of min terms, sum of product standard form, and add extra annotation to K-map to help you plot the expression. Okay, let me erase the old K-map here. And bring this one here. Okay. All right. Now, what annotations are we talking about? And first of all, this is the example here. Okay, this is our example. If is this if here. I'm given if in a sum of product form. Okay, already. So I don't need to do anything. I just can plot it right away. Okay, how do I plot it? Basically, I first need to know where is A and A complement, and where is B and B complement, and where is C and C complement, and where is D and D complement. Okay, so the first thing is to identify A. Okay, so A is this part here. A is 1 here, so this is my A, which is the lower or the last 2 rows of the K-map, because A is 1 here, so my A here is 1. Okay, my A is uncomplemented here, and it is a complement here. Anything that belongs to here is a complement, but I'm not drawing that. Okay, it is known. Now I annotated A, so you know that a complement is anything else. Okay, B is 1 here. Okay, so the middle 2 rows is B, so this is B. Okay, and then C is going to be 1 for the last 2 columns, right? C is going to be 1 for the last 2 columns, so this is C, and D is going to be 1 for the middle 2 columns. Okay, so this is my D, and of course the first and last column are the complement. Okay, now it's just a matter of taking intersections of literals. Okay, so I have the first product here is AB in the function. Okay, so how do I plot AB? Okay, I plot AB by intersecting A with B and then putting ones in the intersection result. So A is this region here. Okay, the lower 2 or the last 2 rows, and B is the middle 2 rows. What is the intersection? It's the third row, right? The third row represents AB. So I just put ones here, right? Next, A, B complement, C complement. So where is A? It's the last, it's the second half of the K-map, okay? And B complement is going to be the first and last rows, okay? First and last rows. So what is the intersection between these two? It is going to be the last row, right? Just the last row. Do you see that? Okay, then the last row intersected with C complement. So C complement is the first and second column. So this one here intersected with these two columns is 8 and 9. That's it. Okay, 8 and 9. Okay. All right. Now a complement BD. All right. A complement BD. So a complement is this part here, and B is this part. So the intersection B is this part actually. So the intersection is this part. Okay. And then D is this part here. And so 5 and 7. This is 5 and 7. All right. Finally, we have A, C complement D. A. Who can tell me what is this now? A, C complement D.
13 and 9.
13 and 9. A, C complement, A, C complement, and D. Excellent. Yeah. So it is already covered by one. So from this, we immediately know that this is redundant. It's covered by some other products. Okay. Now let's minimize this function. Who can tell us which, what can we group now?
We can take the middle.
The middle 4. You mean the exact
seven.
middle of the K-map. Okay, the 4 cells that are in the middle of the K-map. So these, you mean these, right?
Yes.
And these are nothing but
BD.
My F is B D. Okay, ORed with. Okay. Different color.
Fourth in the corner.
The corner.
Yeah. I mean, the third
Tell me the
row.
numbers, the midterm numbers.
13, 12, 8, 9.
Excellent. Yeah. So you take the big box. Okay. Because it's not included in a larger rectangle, and it is a power of 2, and it's rectangular. Okay. And what is this in algebraically? So it's A ended with
C complement.
right? A ended with C complement. You can see it immediately from the annotation, right? From the annotation tells you exactly what is this. Okay, the final one is
third row.
third
Row.
Excellent. Yeah. So the third row completely is third one. Okay, and that corresponds to what?
A and B.
A and B.
A, B. Excellent. Yeah. So this is the minimum form of the function. Let's see whether we can do it algebraically or not. Okay. Can we prove that this is indeed the simplest form algebraically of this function or not? Okay. Can you do that? Let's see. So this AB with AB complement C, okay, can take A as a common factor and then get rid of the B complement. So AB with AC complement, right? And then I have AC complement with AC complement here. So this will go, okay? So I have AC complement with AB and then A complement BD, A complement BD. So the final expression that we had is AB ORed with A C complement ORed with A complement BD, okay? So we have B here, okay? And B here. So we can take a common factor and then get rid of this A complement using simplification rule. So we wind up with the same expression here, okay? All right, any question? So algebraically or K-map, both result in the same minimal expression, okay? I just did it verbally, I'm sorry, I didn't do it by writing, but you get the idea anyway. It's a good practice to do it yourself. Any question? We don't have time to, in fact, cover more topics, but next time we will see examples like this, okay? This is actually simple. So let's do this, okay? Let's do this. So this is basically the consensus theorem, okay? So to plot this in the K-map, we have AB, okay? A is this one here, the second row, and B is the last two columns, and C is the middle two columns, okay? So AB is the intersection of this with this, which is basically this, okay? And then a complement C, the intersection with this and this, which is basically these two ones, okay? And then BC is going to be B with C, okay, which is the third column, okay? And you can tell this is the consensus theorem, so you can tell that this is going to be AB ended with BC, ended with a complement C, okay? And you know that from the consensus theory or theorem that BC is redundant, okay? Any question? All right, I'm going to stop here. Let me stop recording.